In this video, we're going to explore solving multiple step equations using the distributive property and also discuss the idea of combining like terms. So first, as a review, we want to look at how do we solve a multiple step equation. In our last video, we talked about solving two-step equations, and I want to remember that I can even apply this process towards 3, 4, and even more step equations. Now the key idea is that we want to do things in the opposite order of PEMDAS. So I'm going to underline that for emphasis. Opposite order of PEMDAS. So normally the last thing we do is eliminate addition and subtraction. We notice that the first thing we're going to do is eliminate things that are added or subtracted to our variable. Then we're going to deal with the multiplying and dividing, which is normally our second to last thing. Third, we're going to go ahead and deal with any exponents. And then fourth, normally we deal with things inside parentheses first, but because we're undoing the order of operations, the parentheses are going to be the last thing. So again, that key idea here is the idea of undoing PEMDAS, or going in the opposite direction as we solve. So here's our first option, and I see that there's quite a few operations. So we want to look at all of them. And I look here first, I see that there's multiplication between 2 in the parentheses. Inside of the parentheses, I see that x is being divided and subtracted. And then outside the parentheses, again, I see addition. So we want to think about which one to do first. Now, when we are simplifying, we always start inside the parentheses. But remember, we're undoing the order of operations, or undoing PEMDAS. So I want to start by doing the last thing we normally did with PEMDAS, which was dealing with any addition or subtraction I see outside of parentheses. Now parentheses are going to be the last thing we deal with. So if I look here, I actually see that there is addition outside the parentheses. So this has to be the first thing that we deal with. So I'm going to go ahead and drop our line separating the two sides of our equation. And I have to undo the addition by 4 by applying the inverse. And remember, the inverse of addition is subtraction. So I'm going to subtract 4 from both sides. And again, the key thing is that we do perform an operation not only to one side of the equation, but the other as well. This is going to leave me with 2 times, in parentheses, x over 4 minus 2. The 4 and the negative 4 add to 0. So now we're just left with equals 12 minus 4, which is 8. Now again, I need to identify the next step that I need to cancel. We still want to be working outside the parentheses, since that's going to be the last thing we try to undo. So now I'm going to zero in on this multiplication by the 2. And again, I know it's multiplication because there's no operation between the 2 and the parentheses. So to cancel this, I have to apply the inverse of multiplication, which is division. So I'm going to divide both sides of the equation by 2. Now, just to be clear, what's really happening is that we're recognizing that this becomes 2 over 2 times, in parentheses, x over 4 minus 2 equaling to 8 over 2, which is 4. But I don't actually need to write this 2 over 2 over here, because I know that that is just equivalent to multiplying by 1. So we can actually remove this, and we recognize that we use that word cancel, right? The 2's cancel. But really we're recognizing that the 2 and the 2 divide to 1, and that multiplication by 1 is unnecessary. So at this point, I can even rewrite this left-hand side. I really don't need the parentheses around the x over 4 minus 2, because nothing else is left. So I can just consider now x over 4 minus 2. Now that all the operations outside of the parentheses are gone, we can start working inside the parentheses. So I'm looking at both sides of the equation. Again, I'm undoing the order of operations. So normally we would do division before, but because we're doing in the opposite order, the next thing I'm going to deal with is this negative 2. Right, again, opposite of the order of operations. So we're undoing subtraction before multiplication. So I'm going to go ahead and add that 2 to both sides. And we can come over here and use some of this check space to finish up our problem. I'm left with, on the left-hand side, x over 4 equals, notice how the negative 2 and the positive 2 over here both add to 0, so those eliminate. And I'm left with 4 plus 2, or in other words, 6. And now we're almost done. The only operation I have left with the x is division by 4. I have to cancel that division with multiplication. So I'm going to multiply both sides by 4. So multiply this side by 4. Multiply this side by 4. And notice that 4 over 4 is the result of that multiplication, equal to 24. And I really don't need to write this 4 over 4, because that's just multiplication by 1. So I can eliminate this, and I can see that my answer then is just x equals 24. So now we want to check our answer, and we can check it by plugging this back into the equation. So I'm going to write 2 times, but instead of writing x, I'm going to plug in the 24 over 4 minus 2 plus 4, and hopefully this all equals 12. So now that I'm checking, I am going to follow the order of operations. The first thing I'm going to do on the inside is the division, because now we are following order of operations. So I need to do this division here before I do the subtraction. So doing a couple steps in once, 24 divided by 4 is 6. Then minus the 2 inside the parentheses should just become 4. And then I can go ahead and multiply, again following order of operations. I want to do multiplication before I do the addition. So see how first we simplified inside the parentheses. Now I'm doing multiplication before addition. And I can see that 8 plus 4 equals 12. And this is true. Next example, again want to solve for x. So I'm going to do the opposite of the order of operations. So I notice here, first of all, that I have this fraction 2x minus 5 all over 3. And the first thing I want to remind you of is that we talked about when I have an entire expression on the top or bottom of a fraction, we almost want to treat them like there's an imaginary pair of parentheses around those top numbers. So simplifying that 2x minus 5 is going to be the last thing we do. Now, following the opposite of the order of operations, the last thing we normally simplified was addition. So the first thing I want to deal with when we're solving is this addition of plus 7. So I'm going to go ahead and do the opposite of addition, which is subtraction of 7 to both sides here. So I'm going to go minus 7 on the left, minus 7 on the right. And this is going to leave me then with, in parentheses, as a good reminder, 2x minus 5 over 3 equals, and then that 12 minus 7 just becomes 5. And again, just to note that the 7 and the negative 7 add to 0. Now, the only other thing outside the parentheses, which is going to be the last thing we deal with, remember, first thing we normally simplify was the parentheses. So that means it's the last thing we're going to solve for. I now have to deal with this division by 3. That's the last thing that's not inside the parentheses. And the opposite, or the inverse operation of division, is multiplication. So I'm going to multiply both sides here by 3. And that multiplication leaves me now with just 2x minus 5. And I don't even need to write it inside parentheses anymore because there's nothing else outside of it. And that's equal now to 5 times 3, which is 15. And again, as a reminder, because multiplication and division are inverses, those divide to 1, which we don't need to write anymore. Good. So now we've taken care of everything outside the parentheses. Now we can start looking at what's remaining, this 2x minus 5. Again, since subtraction is normally the last thing we simplify, this is going to be the first thing I apply an inverse for when I'm solving. So the inverse of that subtraction of 5 is adding 5. So I'm going to add 5 to both sides. And this is going to give me then 2x equals 15 plus 5, or in other words 20. And again, we see that that subtraction and the addition of 5 cancel. So we'll come over here to our check space to finish. Only other thing I have to deal with now is this 2, and since there's nothing there, I notice it's being multiplied. I'm going to apply the inverse of multiplication, which is division, by the 2, leaving me just with x equals 10. And again, just as a reminder, multiplication and division are inverses, so the 2's divide to 1, leaving us just with x. So now we want to check this. I'm going to plug in the 10 for this problem. So plugging in, I'm going to put in parentheses 2 times 10 for the x, minus 5, so there's the top of my fraction, all over 3, plus 7, and hopefully this equals 12. So now that we're simplifying, I am going to start inside the parentheses. Looking at this 2 times 10 minus 5, I'm going to do the multiplication first, which is 20, and then the subtraction of 5, leaving me with 15 over 3. Plus 7 equals 12. So again, just to be clear, inside the parentheses, that underlined part, I did the multiplication 2 times 10 first, then the subtraction following the order of operations as we simplify. Now here I'm going to do the division before I do the addition following the order of operations, leaving me with 15 divided by 3, which is 5 plus 7, and I confirm that that does equal 12. So we know we did this right. Now sometimes we actually see some equations with multiple variables. So for up till now, all the problems I've given you in these solving problems have always contained just one x that we've been getting it by itself. But what do we need to do if we have equations that have more than one x term? So here's what we need to do. In order to solve these equations, you must first combine like terms. So combine, and I'm going to put in quotations, like terms. And we want to define what I mean by this term, like. So terms are considered like if they both contain a variable. So if they both contain a variable like x, then we can combine them. But they're also considered like if they both do not, and I'm going to put that in capitals, not contain a variable. So if I have two things that, for instance, contain x, we can combine them. And if I have two things that do not contain x or some other variable, then we can combine them. And here we see an example of that. First, I look at these two terms, 4x and 3x. These are like terms since they both contain x, and I notice that 4x and 3x make a total of 7x. So we're just adding up and basically saying if I have 4x's here and 3x's here, I must have a total of 7x's. Similarly, I know that 5 and 4 are also like terms since they both do not contain a variable. Since they are just integers, we can combine them like always and make 9. And then finally, 2x and 6 down here, I see are not like terms. I can't combine a term that is one containing an x or a variable and the other one that is not. So here we see our first example, and I can see that I have multiple x terms here, 4x and 6x, and I also have multiple non-x terms, this -9 and this 21. So the first thing we need to do if we're going to solve one of these equations is try to combine our like terms. So first, I notice that I can combine 4x and 6x for a total of 10x's, and I can combine these because I notice that they both contain that variable of x. So they are like terms. So this leaves me with 10x minus 9 equals 21. And at this point, we actually notice that we're just down to a regular equation. Now that I have a single x term, my goal returns to trying to get x by itself. So I'm going to do inverse operations. The last thing we normally simplify is addition and subtraction. So this subtraction by 9 is going to be the first thing I try to move to the other side of the equation. So I'm going to go ahead and then put my equal sign down here, separating that down. And I'm going to apply the inverse of subtraction first, which is addition, adding 9 to both sides, leaving me with just 10x because -9 and the +9 add to 0. And then this is going to be equal to 21 plus 9, which is 30. And now the only thing we need to simplify is getting rid of the 10. Since 10 is being multiplied by x, I want to apply the inverse of multiplication, which is division. And this leaves me with just x equal to 3. And a reminder that a 10 over the 10 just divides to 1. So we do not need to write the multiplication by 1. Or in other words, those cancel. So now I want to check. I'm going to plug in x. And we notice that I actually have two places to plug in. First, I have to put 4 times 3, because I had an x after the 4. But I also need to put 6 times 3, because I had an x there as well. And then I'm going to write -9 equals 21. And we want to check this. So following simplification, I have multiplication, addition, and subtraction. I need to do these multiplications first by the order of operations. So 4 times 3 is 12. plus 6 times 3 is 18. Minus 9 is going to equal 21. And now all I have is addition and subtraction, so I'm going to simplify left to right. So first I'm going to combine this 12 and the 18, leaving me with 30 minus 9 equal to 21. And I can confirm that this does give me 21 equal to 21. Here's another example, and we see a few more terms here, but again we see some like terms. I see two x terms, 14x and negative 5x, that can be combined. And I also see two non-x terms, 5 and negative 7, that can be combined. And as long as we group the terms signed with them, so for instance, as long as we keep the 7 negative and the 5x negative, I can simply combine these together. So first, let's start with the 14x and the negative 5x. 14 minus 5, that leaves me with 9x. Similarly, the 5 and the negative 7 in the blue here combine to a negative 2. And I'm still left with equal to 25. Good, so again, all we did was combine our like terms. The 14x and the negative 5x gave us 9x. The 5 and the negative 7 gave us negative 2. And now we're back to solving. So by order of solving, I want to undo PEMDAS. The last thing we normally do in PEMDAS is addition and subtraction. So the first thing I'm going to deal with is that subtraction. And I'm going to go ahead and add 2 to both sides of this equation, leaving me with 9x equal to 27. And again, the negative 2 and the plus 2 are inverse operations. Those just add to 0, so those cancel. And now I see 9x is being connected by multiplication. I'm going to apply the inverse of multiplication, which is division to both sides, leaving me with x equals 3. Noting that 9 over 9 divides to 1, and we don't need to write multiplication by 1. So now I can check this. Always good to go back to our original problem. So I'm going to plug in 5 plus 14 times, I'm actually going to put the 3 in for that first x, minus 7, minus 5, I'm going to put 3 in for that second x, and I'm hoping that the whole thing simplifies down to 25. So again, I see a couple of multiplications. I need to do the multiplication before addition and subtraction, because we are now simplifying and following the order of operations. So it looks like I get 5 plus 14 times 3, which is 42. Minus 7, minus 5 times 3 is negative 15. And hopefully this all equals out to 25. Now I'm just going to go left to right, following the order of operations. So first, 5 plus 42 is going to give me 47 minus 7 minus 15 equals 25. Still going to go left to right because all I have now is addition and subtraction. So 47 minus 7 gives me 40 minus 15, which is 25. And I can confirm that 40 minus 15 is 25, so we know that we did this correctly. Now, even if we have multiple terms, sometimes we face another problem. And here's an example. The question now is, can I simply combine the 4x and the x? And the answer is no, I can't right now, because the x is inside these parentheses, which are being multiplied by 2. So this all goes back down to the order of operations. I notice here that between the 2 and the parentheses there's nothing, so there's multiplication. I can't add 4x and x before I deal with that multiplication because we need to follow the order of operations. So we have to figure out, well, how can we work around this problem? How can I deal with this multiplication, which I'll write in here, multiplication. How can I somehow deal with this before the addition and subtraction so that we're not violating our order of operations? And here's a rough example of how. 3 times 5 plus 2, we've dealt with problems like this before. If I start over here looking at how we solve this with the order of operations, I always would have just started inside the parentheses. I would have added 5 plus 2, giving me 7, and then I could multiply 3 and 7 and get 21. But what we notice is that we can actually do this a different way using a new property called the distributive property. If I go back to our original problem, my claim is that we can actually do this multiplication on the outside before we deal with inside the parentheses, as long as I multiply to both terms. Now let's test this out to see if it works. If I do 3 times 5, that gives me 15. And if I do 3 times 2, that gives me 6. So again, if I distribute through 3 to 5, and then also 3 times 2, I can now see that the remaining 15 and 6 add together and give me 21. So these are in fact equivalent, and this gives us a nice little workaround. If I need to deal with that multiplication before I deal with the addition outside, I can go ahead and multiply that outside number as long as I multiply it by every number inside the parentheses. So let's see a few more instances of this in action. I've had one demonstrated already. If I multiply in this first one, 3 times x and then 3 times 2, I notice that 3 times x gives me 3x, and then the 3 times the 2 gives me the 6. So again, going through that one more time, I can see that 3 times the x gives me this 3x over here, and then if I do 3 times the 2 in the blue, that gives me the 6. So we can continue with this idea. The second one, I could use the distributive property. Do 4 times 2, which would give me 8. And then I could do 4 times negative 2x, which would give me negative 8x. And we see now that when I'm done this, I now have two separate terms, 8 and negative 8x, but neither of these are now combined underneath those parentheses, and now I'm just down to addition and subtraction. So one more example. If I distribute the negative 2 to the 3, that gives me negative 6. If I distribute the negative 2 to the 4x, that gives me a negative 8x. And then if I distribute the negative 2 to the negative 2, that gives me a positive 4. So let's see if we can use this distributive property here to solve a couple more problems. So if we actually return to that last problem that stumped us, we recall that the problem was that I didn't know how to add the 4x and the x together because I had this pesky multiplication of 2 outside of the parentheses. But now we see that as long as we use our distributive property, we can actually get around this. So my argument is, well, let's just multiply through 2 times 2 and then 2 times x, and then let's see if this is going to allow us to then combine. So I'm going to still have the 4x on the outside. If I multiply the 2 times the 2, that gives me 4. And if I multiply the 2 times the x, that gives me 2x. And I notice that the parentheses are now gone, and we're actually all set now to combine some like terms. So we're back to a problem very much like the ones we just solved before, where I have two like terms, 4x and 2x, which we can actually combine into 6x plus 4 equals 22. And now we're just down to solving. So I'm going to put up our line down the middle of the equation here. The first operation I need to cancel is the last one by the order of operations. So I have to deal with this addition here, and I'm going to deal with this addition by the inverse of addition, which is subtraction. So I'm going to subtract 4 from both sides, leaving me with 6x equals 22 minus 4, which is 18. And again, I notice that 4 and negative 4 are inverses. They add to 0. And then I have the 6 times the x. I'm going to do the inverse of multiplication to both sides, which is division, leaving me with x equals 3. Again, noticing that 6 divided by 6 divides to 1, and we don't need to write multiplication by 1. So I can now check this. And it's always important to check, especially as problems get more and more complicated. So I'm going to write 4 times. In place of the x, I'm going to put that 3 we just found, plus 2 times 2 plus, again, I'm going to put 3 in for x, and hopefully this whole thing simplifies down to 22. So I can follow our order of operations now that we're simplifying. First thing I simplify is inside parentheses, so that gives me 4 times 3 plus 2, and that simplifies down to 5 when I add inside the parentheses. So parentheses are taken care of. There's no exponents. Now I can multiply and divide. And I see two multiplications right here. 4 times 3 and 2 times 5. And that leaves me with 12 plus 10 equal to 22. and I can confirm that 12 plus 10 is in fact 22. So I know I've done this correctly. Our last problem, a very similar one. Again, we face the same problem. Right now I can't combine this negative 2x and the 4x because the negative 2x is inside parentheses and I have this multiplication of 3 on the outside. By order of operations, I need to do multiplication before I can do the addition and subtraction of negative 2x and 4x. So unfortunately, we're stuck, but luckily for us, we've learned the distributive property. I can do this multiplication by 3 first, as long as I distribute it through to both the 5 and the negative 2x. So 3 times 5 is 15. 3 times a negative 2x is negative 6x. And then I'm still left with that 4x equal to the 19. And I notice now that I do have two like terms that both contain x, negative 6x, and positive 4x. And I can actually combine those into a negative 2x. So I have 15, negative 2x, and this is equal to 19. Okay, and now since I have a single x variable, I'm going to go ahead and solve for this x variable. The first thing I have to deal with is addition or subtraction. And I noticed I have this 15 here. Now you might be saying, well, I don't really know what's happening to the 15. There's nothing in front of it. I notice it's a positive 15. So in order to cancel a positive 15, I have to take away 15. So I'm going to take away that 15 from both sides. And if you want, you can even put a plus in front of it if there's nothing there, so that you recognize that really there's kind of an imaginary addition. So this leaves me with negative 2x equals a positive 4. And again, the positive 15 and the negative 15 over here add to 0, because those are inverse operations. Now I notice that the negative 2 and the x, the only operation left is multiplication. So I'm going to do the inverse of multiplication, which is division. And I notice that x is then going to equal 4 divided by negative 2, which is a negative 2. Noticing that negative 2 divided by 2 is 1. We don't need to write 1. So, now I can come over and check. I'm going to keep my original equation, 3 times 5 minus 2 times a negative 2 plus, and I should put another parenthesis there before we finish. So plus 4 times negative 2, and I'm hoping that this is going to equal 19. So let's see. I have to follow order of operations. So I'm going to start inside the parentheses, and more specifically, there's subtraction and multiplication. I have to start with multiplication, following order of operations. So I'm going to do 3 in parentheses, 5, and then negative 2 times the negative 2 is a positive 4, plus 4 times negative 2 equals 19. So, still inside the parentheses. Now I can simplify the 5 plus 4, giving me 3 times 9 plus 4 times negative 2 equals 19. Now that the parentheses are simplified, I'm moving on to multiplication and division. And I see there's two multiplications here. So 3 times 9 is 27. 4 times negative 2 is a negative 8. And I can confirm that 27 plus a negative 8, or in other words, 27 minus 8 is 19. So we have, in fact, done this correctly. At this point, I'll now ask you to do the 6 on-your-own questions. And you've noticed that I've given you the solutions to the on-your-own problems. But I am only going to take credit with as long as I can see the work to these problems. So use these solutions to check your work, but make sure you are going through these and showing your work on every step to show that you truly understand the problems.